The first two learning objectives we're going to look at for Chapter 7 is in 7.1. It's going to be rewrite exponents to radicals and rewrite radicals to exponents. So first let's review what are exponents and what are radicals. If we look at something like this is fairly abstract, but something that would be like b squared equals a. Here's what I mean. What if I asked you some number squared equals 9? And I asked you what is that number? We all can realize that 3 squared, which is 3 times 3 is 9, so b would therefore equal 3. Another one, maybe I said b squared equals 16. What is b in this case? B would have to be 4. Well, another way to look at it is not to say what number being squared, but to come on in and instead, for 9, what if I said what is the square root of 9? The square root of 9 is a radical symbol. So for that one, the radical symbol, let's just use 9, would be the square root of 9. And we all know the square root of 9 means what number twice is going to get you 9. The answer in this case would be 3. Now, what does the exponent look like for it? Well, that radical symbol can actually be written as an exponent. And what I'm going to do is instead of doing this equation here, I'm going to reverse it. The radical symbol for square root means 9 to the 1/2 power. So just make the connection. If I ask you what is 9 to the 1/2 power, I'm really asking you what is the square root of 9. Remember the square root of 9, what number 2 times gets you 9? The final answer, therefore, would be 3. And this is called the squared root. Now, another type we can look at is called the cube root. And that deals with the 3 because cubes are 3. So here's an example of that. If I say the cube root, here's what this looks like as a radical. I'm going to look like a little square root symbol, but I'm going to put a little 3 in there. And I'm going to put the number 8. So what cube root means is this. What number 3 times gets me 8? It has to be the exact same number in which one's going to work. If you try it, 2 times 2 times 2 will actually equal 8. So the cubed root of 8, what number 3 times is 8, is the answer 2. Now that can also be written as an exponent. That's just going to be 8, not to the 1/2 power, but to the 1/3 power. Let's look at one more. We have the 4th root of a number. So let's switch it up. What if I ask you to find the 4th root? Put a little 4 here, and I'm going to say the 4th root of 16. What's the answer? Well, what that means is this. What number 4 times is 16? And you just have to stop and think. Try 1 times 1 times 1 times 1, that's 1. What's 2 times 2 times 2 times 2? Well, this is 4. 4 times 2 is 8. 8 times 2 is 16. So the answer here is going to be 2 again. To write that radical as an exponent, it is going to be 16 to the 1/4 power. So ultimately, when you get to the vocabulary word, what nth root means is this. You're going to write it like the radical symbol. You're going to put whatever root it is there. It's going to be the nth root, the 2nd root, the cube root, the 4th root of some number a. That can also then be written as an exponent. You would just do a to the little exponent of 1 over n. Whatever n is. Again, it could be the square root, which is 2, the cube root, which is 3, the 4th root, which is 4. If we look at how to write from radicals to little exponents and backwards, here's some good rules. And if you look at this right here, what it's going to say is if you have a to the m over n power, this little n guy on the bottom, that is your root or your radical. So you can actually pull that apart, and I'm going to take the m out and put it out over here. And then when you notice that a to the 1 over the nth power is just written as a radical like that, and the m sits there. The other thing you need to be cautious of is, remember from chapter 6, we do not like negative exponents. If you have a negative exponent, just put it over 1, and you're going to drop it down. When you do that, the exponent now becomes a positive value, and then we're still just going to pull that little exponent apart like we did before. We're going to take the fraction of m over n. We're going to pull out the little m by itself. Then we're just left with 1 over n. And what they've done here is they put the little radical first, because that little fraction is now considered that radical symbol, kind of like that square root symbol. You can rewrite that fraction as a square root type of symbol, and then keep the m there as a normal exponent. So let me show you what I mean if I go backwards on this one. If we take a look at this up here, this says the cubed root of 2. Now the cubed root of 2, remember the cubed root can also be written as an exponent. That's the exponent 1/3. And then we have this little exponent 4 on the outside. So what do you do to two exponents that are right next to each other? You multiply. So you're going to multiply, you're going to do 2 1/3 times 4. With fractions, you're just going to go straight across, so it's going to become 4/3. So the answer is going to be 2, and 4/3 is your little exponent. So that's taking a radical and converting it to a rational exponent. So if we look at the second one, this is the 5th root of 9. So the 5th root is the exponent 1/5. Again, I have two exponents right next to each other, so I'm going to take the 1/5. I'm going to times it by 7. When you multiply fractions, by the way, I can make 7 a fraction by putting it over 1. Just go straight across. So 1 times 7 is 7. 5 times 1 is 5. So now I took this radical and rewrote it as a rational exponent. Okay, let's look at a few more. Let's take this radical here, and I can tell it's a radical because, again, this symbol, this square root looking symbol is called a radical. This is not the square root. It has a little 4 there, so it is the 4th root. So I'm going to take the 5. The 4th root is the 1/4 power, and then there's a little 3 on the outside. I'm going to multiply 3 by 1/4, so I'm going to do 3/1 as a fraction, go straight across. So I get 5 to the 3/4 power, and that's my answer. Letter B, let's do this. We're going to have here 1 over. This is the 6th root of 4, so I'm going to keep the 4 down there and do a 6th root, which looks like that. Now, what they're going to want you to do is on rational exponents. They don't want those on the bottom, so they're going to ask you to move it to the top. When you move it to the top, remember what happens to that exponent. It actually will become a negative exponent. So that is what the rational exponent looks like compared to the radical. Let's try 3 more. Here we have radicals, and they want us to write them as rational exponents. Again, I always start by taking that radical. This is the 1/5 power, so I'm going to raise it to the 1/5. And I have a 2. Again, these two exponents are right smack dab next to each other, so I multiply. Just go straight across. So this is 2 to the 2/5 power. I circle that. This guy here, number 12, I'm going to change it. It's the 5th root, so it's 1 over 3 to the 1/5 power. We don't want that exponent on the bottom, so we're going to bring it up. However, when we do that, we must change its sign to negative 1/5. Number 13 is similar. This is the 4th root of 13 on the bottom of a fraction, so keep it down there. So it's 13 to the 1/4 root. For my final answer, I'm going to bring it back up, so it's 13 to the negative 1/4. Now let's reverse it. Let's take the rational exponents and rewrite them as radicals. So this one right here, we have 7 to the 2/5. And I'm going to rewrite it like this. Now that 2 is just like it's 7 squared, really. But the 5 there is the root, because it's on the bottom of the fraction. So what I'm going to do on the side is just make note of this, that 2/5 can be pulled apart. I'm going to pull the 2 out to separate it. Then I would just be left with 1/5. Because I know if I multiply these two together, I will get 2/5. So what I'm going to do is I'm going to rewrite 7 over 2/5 as 7 times 2 times 1/5. Now I do want to write this as a radical, and this little guy right here, the 1/5, is going to give me that radical symbol. So I'm just going to switch it around and say 7 1/5 times 2. You can do that with multiplication. Remember, 1 times 2 is the same as 2 times 1. Then what I can do, I know 7 to the 1/5 power would just be written as the radical symbol with 7 in it. Careful, I want the 5th root, so I put that there. Then I'm going to wrap it up and keep the squared out there. And that would be my final answer. This other one here, let's take the rational exponent of 2 to the negative 2/3 power and clean that up. Remember, we don't like negative exponents, so we're going to put it over 1. To get rid of the negative, drop it down. So that's going to give us 1 over 2 to the positive 2/3. Now that 2/3, by the way, I'll do it over here. I'm going to pull out the 2. I'm going to put it over here this time, the far side, and I'm left with just 1/3, because 1/3 times 2 is 2/3. So I can rewrite this by pulling up that exponent, separating it out. So I'll get 1 over 2 to the 1/3 power times 2. That 1/3 power is the radical symbol, the cube root, so I'm going to put a little radical symbol around it. Careful, that's a square root, put a little 3 in there, that's cube root. And on the outside, I am squaring the whole piece. So I can do that, and that would be my final answer. Now it's going to be important to note, though, if you look at these two answers on the screen, they can be written a different way. Here we can write it where we have the number inside the radical and the exponent on the outside, but you can also write it as the 5th root on the outside, but you can do 7 squared. So this squared can go into here. You would then simplify 7 squared, which is 49, and don't forget the 5th root. So this is an equivalent answer to this other problem. In a similar fashion, this one here can be written such that the squared here is not on the outside but on the inside. If you rewrite that, you'd still have the 1. We'd have the cube root, but then we would do 2 squared. If you simplify that, you would have 1 over the cube root of 4, and then this is an equivalent answer to that one. Let's wrap up this learning objective. I'm going to show you 3 more if you want to see them. So let's go ahead and do this really quickly. 15, I'm going to break up the 2/3 into a 2 and a 1/3. That 1/3 is the radical symbol, so I'm going to make the radical sign, and I'm going to make sure I put a little 3 in there. And then I'm going to wrap it up, and then I'm going to put the 2 on the outside. For 15, I first want to get rid of all negative exponents, so I bring it down. 11 to the 1/3. Now, the 1/3 doesn't need to be broken up. It's already just saying that means cube root, so I can just rewrite it as this, my radical symbol of 11. Careful, it's a cube root. Put a 3 there, and I have my answer. This last one, number 16, again, first get rid of your negative exponent, so it's 1 over 29 to the 2/5. 2/5 can be broken up. I'm going to write it like this. I'm going to put a 2 and then a 1/5. Now remember, the fraction is that radical symbol, so I'm going to actually come in here and do the radical symbol over the 29. It is the 5th root, so I put a little 5 there. And then I'm going to wrap it up and keep the squaring there, and that is our final answer. Now that we have the 3 final answers here for all these problems, let's again just rewrite them in the other format where the exponent is brought to the inside. So keep in mind this one here can be rewritten where we would have the cubed, and then it would be 15 squared. 15 squared is the number 625, so we could write it in this fashion. This guy here, there's really nothing else to have to do to it. There is no exponent on the outside, so this one is done. But this one here can be rewritten such that the squared is on the inside. So to rewrite that one, 1 over, I would do the 5th root of 29 squared, which then is going to be 1 over the 5th root of 841. So this is an equivalent answer to that one.